Hi, my name is Mr. Chu and you're welcome to my study room. Today I'm solving objective questions 16, 18, 23, 27, 33, 34 and 40 of the 2023 WASSCE General Mathematics paper written by Nigeria. I've decided to solve these questions together because I feel like they have a lot of things in common, or more or less they are under the same topic. So let's take question 16 and it reads: the radius and height of a solid cylinder are 8 centimeters and 14 centimeters respectively. Find correct to 2 decimal places the total surface area. Let's first start by underlining the key facts from this question. And the key fact I would like us to underline are the fact that the radius is 8 centimeters and the height is 14 centimeters because of the word respectively here. Right. And another fact is the fact that they said the cylinder is a solid cylinder, meaning it is a closed cylinder. And also we have to find correct to 2 decimal places. This is very important because it tells us how we should run our final answer to. And then now finally to what we are solving, the total surface area. Right. Now that we have this, let's now go to the question. A solid cylinder is a closed cylinder. So let me just put that here. And I would like to extract the information. The radius, let's call it R, equals 8 centimeters. And also the height, let's call it H, equals 14 centimeters. Now let's call the total surface area TSA. And the total surface area of a cylinder, for those who might not know what a cylinder looks like, this is how a cylinder looks like. Yeah, so this is a cylinder. Remember, they say it's closed. So let's shade here as a closed cylinder. And a cylinder has 3 faces. The first face, which is the base, the second face, which is the top, and then the third face, which is the curved surface area. So the total surface area of a cylinder is just finding the areas of each of the 3 faces and putting them together. The base is a circle, and the area of a circle is pi r square. So let's write that, pi r square. And the top or the lid is also a circle, so the area of that is also going to be pi r square. And now the curved surface area is 2 pi rh. Right, we can just substitute this directly into it, or we can simplify this, and these are like terms, so we can simplify further. It depends on whatever you want to do. So this is the same as 2 pi r square, because 2 of these, plus 2 pi rh. Again, we can decide to substitute the values here or still break it down to 2 pi r multiplying. When we divide here by 2 pi r, we are going to be left with r, and when we divide here by 2 pi r, we are going to be left with h. So that becomes the simplified version. You can just substitute the values here and work, or you simplify then you substitute, just make the calculation a bit smaller for you. Now let's go ahead and substitute the values, and the total surface area now becomes 2. Remember the question said we should take pi to be equal to 22/7. So 2 times 22/7 times our radius is 8 centimeters. All of this multiplying, radius is 8 plus height is 14. And 2 times 22 times 8 will give us 352 divided by 7. And then this one multiplies 8 plus 14 is 22. And when we simplify that together on our calculator, we are going to have 1106.2857. And remember, the question asks us to solve this to 2 decimal places, which means we are ending it here on the 8th, and that gives us 1106.29, because this is 5, so we round it up to 29 centimeters squared, or square centimeters, since this is area. And looking through the options, the answer is option C. Let's now move to question 18. And question 18 reads that a sphere has radius 3 centimeters. Find in terms of pi its volume. And here the only information we have is the radius of the sphere, and the fact that we are to find the volume in terms of pi. So since we spoke about volume, it will be important for us to write the formula for the volume of a sphere, which is V equals 4/3 pi r cube. So we are just going to substitute the value of the radius into this, and that becomes 4/3 multiplying 3 cubed, then I bring the pi to the last, and this will be 4/3 multiplying 3 cubed is 27, then pi, and 3 goes here, 1 goes here, 9, and 4 times 9 is 36. So remember, the question said we should leave our answer in terms of pi, so our answer is 36 pi, and that is option C. And remember, it's centimeter cube because you are talking about volume. Volume is measured in cubic units. And now let's move on to the next question, which is 23. And question 23 says that an empty cylindrical tank is 140 centimeters in diameter. If 200 liters of water is poured into the tank, calculate correct to the nearest centimeter the height of water in the tank. Take pi equals 22/7. Then again, we would like to underline the key fact from this question. And the first thing I would like us to underline is the fact that the tank is cylindrical. So that's a very important information. And also the diameter is 140 centimeters. And also the amount of water poured into the tank is 200 liters. And again, we should calculate to the nearest centimeter the height of the water in the tank. So not the height of the tank, but the height of the water in the tank. Let's now put this information down. Since this question is talking about the capacity of the tank, then it will be very important for us to write the formula for the capacity of the tank, which is the same as volume. So the volume, remember again, the tank is a cylindrical tank, and I just drew cylinder in the previous question. So the tank looks like a cylinder, and the volume of a cylinder is the base area, which is pi r squared, because the base is a circle times the height. So pi r squared h is the formula for the volume of a cylinder. Now let's extract the information from the question. The radius of the tank is the same as the diameter divided by 2, which is 140 divided by 2, and that will give us 70 centimeters. Then the volume of the water was also given by in liters, so the volume is 200 liters, which is the same as 200,000 cubic centimeters, because 1 liter is 1,000 centimeter cube, And it will be important for us to change from liters to cubic centimeters because the radius or the diameter was given in centimeters, so that we can have the same unit to work with. Remember, the value of pi is already here, so you should take pi equal 22/7. And let's not forget that the h is what we are solving for. So now, putting this information back into the formula, we are going to have the volume, which is 200,000, equals pi is 22/7 times 70 times 70, which is the same as 70 squared h. And this 7 will divide the 70 here 10 times. And solving further, we are going to have 200,000 equals 22 times 10 times 70 is 15,400. Don't forget to bring your h. And now, since we are solving for h, we divide both sides by 15,400. So divided by 15,400. Then whatever we do to the right, we do the same thing to the left, 15,400. So this and this cancel out. Then 200,000 divided by 15,400 is 12.987, and that equals our height. And the question asks us to calculate this correct to the nearest centimeter. That means correct to the nearest whole number. And that means our h is going to be, we are ending it here. And this next number here is 9, more than 4. So we add 1 to the 2, making it 13 centimeters. And that is option C. Let's get to the next question. Question 27 reads that the length of the diagonal of a square is 12 centimeters. Calculate the area of the square. The best thing for us to do here right now will be for us to sketch the square. So let's do that quickly. Taking this to be our square, the question says that the length of the diagonal, and diagonal is a line that connects non-consecutive vertices of polygon. Alright. The question said this diagonal is 12 centimeters. So let's write that here. And then that is all the information that is given. But we know that the sides of a square are all congruent. The four sides of a square are congruent, meaning they are equal. So it means that if this side is x, then here will be x, here will also be x, and here will also be x. And another attribute of a square we know is that it has 4 right angles. So taking this side, it can be this side or any of the 2 triangles as a right triangle. This is a special triangle, but also we can use the Pythagorean theorem to solve, which is the easiest approach to my understanding. If you can remember how to find the size of the 90, 45, 45 right triangle, which is a special right triangle, then we can use the Pythagorean theorem, which is very reliable. So taking the Pythagorean theorem, then it means that the hypotenuse, which is 12 squared, is going to be equal to x squared plus x squared. And 12 squared is 144, be equal to 2x squared. We're solving for x, so the first thing will be to divide through by the coefficient of x squared, which is 2. So divided by 2, whatever we do to the right, we do to the left. So 144 divided by 2 is 72. Then this gives us x squared. We are solving for x and not x squared. So how do we remove the square? I'm sure you'll tell me that we take the square root of both sides. So we take the square root of this and we do the same thing to the left side. And this square cancel the square root. So not to do any approximation, we'll say that x equals square root of 72. We are now going to work out the area of the square. The formula for the area of a square is L squared, where L is the length of the side, and in this case that is our x, the value for our x. So our area is simply going to be square root of 72 squared. and we know that the square will cancel the square root, and our answer is going to be 72. So the correct answer to this question is option C, which is 72 square centimeters. Let's move on to the next question, question 33. Question 33 reads that the angle of a sector of radius 3.4 centimeters is 115 degrees. Find the area of the sector. This question gives us the radius of the circle as 3.4 centimeters and the angle of the sector, which is 115 degrees, and we have to find the area of the sector, and that is where we start solving the question from. So the formula for the area of a sector, let's call it A, is theta over 360 multiplying the area of a circle, which is pi r square, and theta is the central angle of the sector, or the central angle made by the sector. So in this case, that central angle, which we are calling theta, is 115 degrees, and then the radius of the circle is 3.4 centimeters. So our area, which we are calling A, will now be 115 divided by 360 times 22 over 7, which the question asks us to take as the value of pi, then times 3.4 squared, or the same as 3.4 times 3.4. Solving that with the calculator, we are going to have 11.6059, and the question didn't tell us to how many decimal places, but looking at the answers here mean that to one decimal place, so we are ending it here, and the correct answer to this question is going to be option B, 11.6 square centimeters. Let's move on to the next question. And the question 34 reads that the diagonals of a rhombus are 16 centimeters and 12 centimeters. Find the length of the side. Again, just as we did for the question before this, it will be advisable for us to sketch the rhombus. So let me just give a quick sketch of a rhombus. Alright, let's take this to be my sketch rhombus, which I normally describe as a pressed or a stretched square. So all four sides are equal or congruent, and also we've been given the value for the length of each of the diagonals. Some of the basic facts we need to know about a rhombus is the fact that the diagonals bisect at right angles, meaning each diagonal is divided into two. So if this is a longer diagonal, then this is going to be 8, this is going to be 8, and then this is going to be 6, this is going to be 6. Alright, since the sides are equal or congruent, and if the length of one of the sides is x, then we can take one of these triangles as a right triangle. So the x becomes the hypotenuse of the triangle. And solving this using the Pythagoras theorem, we're going to have x squared to be equal to 8 squared plus 6 squared. And x squared becomes 64 plus 36. And x squared becomes 100. We are solving for the value of x, which is the same as the length of the side. So how do we get rid of the square? Yes, we take square root, and whatever we do to the left, we do the same thing to the right. So this square cancels out the square root, and our x becomes square root of 100 is 10, so 10 centimeters, and that is option B. Let's now take the very last question of this video, which is question 40. And question 40 reads that an equilateral triangle has side 2 centimeters. Calculate the height of the triangle. And again, it will be advisable for us to sketch our diagram. And so the diagram is an equilateral triangle. And an equilateral triangle has all sides equal. So let me sketch that. And like I said, an equilateral triangle has all three sides equal. So let's try to locate the height. and this height bisects the top angle and also is perpendicular to the base of this triangle and bisect the base as well. So if this is 2 centimeters, this is 2 centimeters, this will be 1 and this will be 1, and let's call the height h. Then again we can use the Pythagoras theorem to work out for the h. So let's do that. So using 2 as the hypotenuse, then 2 squared will be equal to h squared plus 1 squared. And simplifying further, that's going to give us 4 to be equal to h squared plus 1. And subtracting 1 from both sides, 3 will be equal to h squared. And we are solving for h and not h squared, so we take square root of both sides. 2 cancel the square root, and our h becomes square root of 3, which is option A. And this is where we end today's study. I hope these videos have been of help to you. If yes, then kindly consider subscribing to this channel for more videos like this. Till we meet again in my study room. Bye bye.